Hey guys, Miss Stans here. So today we will be doing lesson 8. The objective is that we'll learn how to do a dilation. Remember, a dilation has a scale factor, and that scale factor is something that we multiply all coordinates by. You have a do now on page 40. I am going to wind up going over that with you, so why don't we just get started together. So we need to graph quadrilateral ABCD, and then we're going to rotate it 270 degrees. So let's plot ABCD first. You should not copy me plotting. You should be able to do it on your own paper. Remember, it's hard to copy points from a board, so you should be making sure your order is correct. X comes first, Y comes second, and after you plot, you can check mine and yours to see if they look the same. The point that a lot of people, well, there's 2 points that a lot of people make mistakes on. Point C at 2, 0 and point D at 0, 1. So be really careful about that. Remember, X comes before Y. So this is quadrilateral ABCD. Remember that the term quadrilateral stands for something with 4 sides. I don't have a ruler, so I didn't draw this beautifully, but it's good enough. That's better. So the main thing is this rotation of 270. So we learned how to rotate by using, remember, my plates where you were able to spin it. So spinning it a quarter turn to the left, that was 90 degrees, and then another quarter turn was 180, and then our third quarter turn made it go to 70. So if you just look at my board for a second, if it ended up here, that would be 90. If it ended up here, that would be 180. It has to end up here. Quadrant 1, 2, 3, 4. Okay, so quadrilateral ABCD has to end up here in quadrant 4. So let's see how we can make that happen without using our plates. So what we can do is actually turn your paper 3/4 turns to the left. 3/4 turns to the left is like 1/4 turn to the right. If your paper is facing this way, that's us turning it 360 degrees. Remember, it was in 270, sorry. Remember, it was in quadrant 1, and now look where it is. It looks like it's in quadrant 4. I'm just going to erase these marks for a second so that they don't throw you off, because really, it's like we're kind of pretending here. We're pretending that our paper is facing normal. We're pretending that this here is the x-axis and this here is the y-axis. If we can pretend that, we can look and see where point A is. Point A is at 4, -1, right? Because it's 4 to the right and 1 down. So I'm actually going to go write that right here, a little sideways. I'm going to call it A prime. We said it was at 4, -1. It's a little hard for me to write sideways. Then I'm going to look at point B. Remember, I'm pretending this is my x-axis and this is my y-axis. So I go to x first, and I have to go to 2, and then I go to y, which is at -5 because I went down 5. So 2 to the right, so B prime is 2 to the right, which is a +2, and 5 down, which is a -5. Then I'm going to look at C. C is just 2 down. I went 0 to the right, so C prime is 0 to the right, but 2 down, so I'm putting a -2. And then D prime is 1 to the right, but 0 up or down. So that's 1, 0. Now I'm going to put my paper back to normal. And I'm going to plot those points that I just wrote down. So 4, -1, 2, -5, 0, -2. Remember, that's the one that people mess up. Careful. And then 1, 0. And if I connect them, it does look like the same shape. I'm just going to move this label here. So it looks like the same shape, but it looks like it turned. It does look like it turned 270 because it didn't go here. That would be 90. Didn't go here because that would be 180. It went over here, 270. It went around 270 degrees. So it says explain how you found the coordinates of B prime. Well, you know what I did? I turned my paper. So I turned my paper 3/4 turns counterclockwise. And then remember, after we did that, we actually recorded the points. So I'm going to say then I recorded the points. Right, that's like what we did right here. That's recording it. Then I put my paper back to normal and plotted. So I know that rotations need a bit more practice, and we will practice them next time I see you. So when we rotate, you really can do it by turning your paper. Um, or like how I showed you the first time, by like using something that helps do a rotation, like that plate activity that we did. But today we're moving on to dilations. They're actually much, much easier to do. You're going to love dilations. Rotations really is the toughest one. So a dilation is a transformation that produces an image that is the same shape as the original, but a different size. So since it's the same shape but a different size, the shapes are not congruent. What we say is it's similar. Similar means somewhat the same. And remember, if the scale factor is greater than 1, the figure becomes larger. And if it's between 0 and 1, like a fraction, it becomes smaller. When we talk about a rule for a dilation, we like to use this capital D and then a little number in the bottom corner. That little number in the bottom corner is called your scale factor. And remember, a scale factor is a number you multiply by. So let's just do number 1 so that we can learn what we're supposed to do with the scale factor. So it's asking us to state the scale factor. If the dilation started at 4, 6, but became 2, 3. So the 4 became a 2, and the 6 became a 3. Isn't that half as big? Yep. So the dilation uses a scale factor of a half. And this is how we write it. A capital D for dilation, and in the bottom right-hand corner, the scale factor. So number 2 asks for the scale factor. Look at A has to go to A prime. 1 became a 5. This one also became a 5. Or the -4 became a -20. Or the 3 became a 15. What number are we multiplying by each time? Yep, you're right, it's a 5. So capital D for dilation and a little 5 in the corner. 5 is your scale factor. The scale factor can be like fractions, and we'll talk about that in a bit. I'm just going to skip number 3. I'm not going to do that. Let's look at number 4. So we have to graph the dilated image of triangle JKL. So JKL is already graphed for us. We have to write down the coordinates. J is at 2, I don't know, we don't have numbers here. 1, 2, 3, 4. At 2, 4. Some people like to number this, like you could go and do it, but honestly, sometimes the numbers get in my way. So sometimes I prefer a graph that's not numbered. If it's not numbered, I know that each box represents 1, so I could figure it out. K is at 1, 1, and L is at 4, 0. Remember, X comes before Y. And look at this little 2 right here. Or look at these words right here. We want to use a scale factor of 2. It means we have to multiply all of these points over here by 2. So when I multiply this 2 by 2, I get a 4. And when I multiply this 4 by a 2, I get 8. We're just doubling everything. Multiply by 2, I get 2, 2. Multiply by 2, I get 8, 0. Remember, 0 times 2 is still 0. And now I have to plot that, right? It clearly says right here we have to graph the dilation. So I have to go to 4, 8. And call it J prime. Then I have to go to 2, 2 and call it K prime. And then finally 8, 0 and call it L prime. When I connect these, they do look similar, don't they? Don't they look the same shape but a different size? So remember, always take a look and make sure it looks like it should. Should look similar when we do a dilation. If I'm going too fast, you could always hit pause, but I'm going to move on. So we have to write down the coordinates again. So M is at 1, 3. N is at 3, 2. O is at 2, -2. Remember, when you go down underneath the x-axis, that's negative. And P, I have to go 1 to the left, so that's a -1 and then 0. And look at it, says use a scale factor of 3. It means I'm multiplying everything by 3. So I'd get a 3 and then a 9. And then a 9 and a 6. And then a 6 and a -6. And finally a -3 and a 0. And then we plot it. And again, if I'm going too fast, you can hit pause. You really shouldn't be copying me plotting points. You should just be looking at the coordinates and plotting them yourself. So we're all doing this at our own pace right now. And if you like your scales numbered, You could go ahead and number the y-axis, right? This is -1, -2, -3, -4, -5, and -6. But honestly, I actually prefer it not numbered. But that's just my preference. Maybe you like it numbered. And then we connect. Does this look like it could be 3 times as big? Sure looks it to me. Do they look the same shape? Yep, they do. These are similar. So these two problems were about doing a dilation that made the figure get bigger. So now, oh, this one also makes it get bigger. We have to multiply by 1.5. It's number 7 that makes it get smaller. Let's see. X is at -4, 2. Y is at 6, 0. And Z is at -2, -4. Now, if you don't like multiplying by 1.5 in your head, go ahead and open up that calculator. So I'm going to use my calculator, -4, and I have to multiply, remember, by this 1.5. So -4 times 1.5. Since it's bigger than 1, it will become bigger. -6. And then I have to do 2 times 1.5. And I get a 3. So I don't need a calculator for this. Next, I'll use a calculator. 6 times 1.5 is 9. I don't have to use it on the 0, though. I know that anything times 0 is 0. And then -2 times 1.5 is just going to be a -3, right? If 2 times 1.5 was 3, then -2 times 1.5 will be a -3. And then -4 times 1.5 I already know is -6 because we did it right here. And now I'm going to plot these points. -6, 3. 9, 0. And -3, -6. There we go. Still similar. Same shape, different size. Let's finally do one that gets smaller. So right here you can see that the scale factor is 1/3. Be careful because it like got cut off right there. It might look like a half, but it's not. It's a 1/3. See that? 1/3. So point M is at 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Good thing, because multiplying 3 and 9 by 1/3 is actually an easy task. N is at 6, 0, which is also a nice thing. O is at 3, -6. And P is at -3, 0. So since all of these are multiples of 3, it's actually easy to multiply by 1/3. I'm going to do some work off to the side. I don't want to open up my calculator. I just want to show you. If I take this first coordinate of 3 and multiply it by 1/3, remember when you multiply with fractions, you can make this look like a fraction and you can simplify. So 3 times 1/3 is actually 1. And then 9 times 1/3. Let's make it look like a fraction again. And this 3 and 9 simplify. This becomes a 3 and that's a 1, so I actually get 3. So the first point is 1, 3. So I would wish that you knew how to multiply without a calculator, but if you need that calculator, you can use it. But I'm going to do these calculations. 6 times 1/3, these simplify to be 2. Anything times 0 is 0. We already did 3 times a third, you get 1. And we already did 3 times 6, so I know that 1/3 times -6 is -2. And if 3 times a third is 1, then -3 times a third is -1. And then let's plot these points. So look at that. Same shape, different size, got smaller this time. And sometimes a dilation is done for us already, and we have to just state like what the scale factor is. When it says describe the dilation, we just really have to state the scale factor. It was dilated using a scale factor of, and now I'm not sure. So the way to pick your scale factor is to pick 2 points that like go with each other. So I'm going to just write down the coordinates right here. The coordinates of point P is at -6, comma 6. All right. And it became P prime. And P prime is at -2, comma 2. So how do I get from 6 to 2? And a lot of people say divide by 3. Well, um, when we do scale factors, we don't talk about division, we talk about multiplication. But divide by 3 is the same thing as multiply multiply by 1/3. Divide by 3, you just put a 3 in the denominator. It's like multiply by a third. So the scale factor is 1/3. So just remember, if it looks like division, it really is multiply by some fraction. And that's all I wanted to do with you. Your homework is number 9 and 10. Now you got to be careful because there's like some things that you're doing here. Um, they told us that r goes to r prime. You have to decide the scale factor. I'm spelling decide wrong. Decide the scale factor. Once you decide the scale factor, you could then fill this in. Once you fill it in, you can then plot it all, right? We have to draw triangle RST and triangle R prime, S prime, T prime. Okay, so make sure you do the whole problem. Then on number 10, there's a lot of transformations that you're doing. So first, you're going to do a dilation using a scale factor of 1/2. Multiplying by 1/2 is the same thing as divide by 2. So figure out what A prime, B prime, C prime, and D prime are. Then you're going to tell me if it's similar or congruent. You don't have to do this. We could talk about that together. Then you have another transformation to do. So after you do your dilation, now you're going to reflect over the x-axis. And then after you reflect over the x-axis, you're going to translate it 4 units left and 3 units up. So pay attention when you're doing this. Make sure you do all parts. And I'll talk to you soon. See ya. Bye.